Okay, well, welcome everybody. This is the fourth COVID-19 Robots and Us weekly discussion with experts. And previously we've discussed the taxonomy of robots being used in COVID-19 response with Robin Murphy. We've talked about the human-robot interactions and the human impacts. And we've also talked to robotics startup CEOs with Linda Pulio from Dishcraft and Vipin Jain from Blended joining us last week, and Ross Mead from Semio and Corey Kidd from Catalia Health, and Travu from OmniLabs joining us in the weeks before. We've talked to roboticists like Guy Cavalcanti and Olga Riley, who've started COVID-19 community response groups, and others like Mark Martin from the manufacturing community, who are helping companies pivot to address the issues caused by the pandemic, which leads us to discussions about the whole supply chain and manufacturing processes, as well as the health, food, and logistics supply chains and processes. And are these going to continue to change to incorporate robots in the future? This has been a wake-up call for the whole world. We want robots to help us, but are the robots here yet? Well, we're going to open the discussion with Rachel McCrafty Sadd, talking about the local COVID-19 response projects that she's involved with and the robots that she'd like to see. We'll also be joined by Robin Murphy, the founder of the field of rescue robotics, with an update on her taxonomy of robots against COVID. And after that, we'll be hearing from our guests, Missy Cummings, expert in robotics safety and professor at Duke University, Michael Sayre, CEO at Cognicept, Rex St. John, the ARM IoT ecosystem evangelist with a very cool project, and Ken Goldberg, director of CITRIS People and Robots Initiative. And just a quick shout out to Erin Pan, who's working behind the scenes with me at Silicon Valley Robotics. And shout out, she's looking for opportunities with autonomous vehicles, and I vouch for her, okay? And Bo Amber, who's the outreach of design and technology lead for Kickstarter. And I'm Andra Kay, the director of Silicon Valley Robotics and founder of Women in Robotics. Now, housekeeping for tonight. If you're not a speaker, please keep your video off and your mic on mute. If you've got a question for our experts, please put it into the chat. We're going to be monitoring it and doing Q&A after our introductions. And now I'd like to start by asking Rachel McCrafty to tell us what robots she wants. And then we'll hear from the rest of our guest speakers. And put your questions in the chat. Over to you, Rachel.
Good evening. I don't know if it's switching over to me or not. It isn't showing me that, but happy to join you. I am joining you from Ace Monster Toys Makerspace, where I am the executive director. We are a member-supported, volunteer-run 501c3. This is our 10th year, so we're doing pretty well before the world lit itself on fire. And as a nonprofit in a very expensive part of the world. And both my community response and my personal response to A, having way too much time on my hands all of a sudden, and B, things not going so well in the world, was to do something about it. I am a local artist. I do interactive public art in Oakland, and when I'm not running AMT and when I'm not doing that, I consult on various communications things. So a little bit about my background. Mostly what I've been doing for COVID response has been making PPE and doing community coordination to help other people make PPE. And without further ado, I will share my screen because I put together a little presentation to show you what I'm working on. So, yeah, Adventures in Sewing PPE, where I could use a fucking robot, because seriously, there are some things that just, like, a robot should be doing this, a human should not be doing this, and I've learned quite a bit in the last few weeks in that regard. And I'm gonna just click over for a sec, make sure I can still see questions here in the Zoom. Or not, you know what, I'll figure that out about Zoom another time. Andrew can let me know if there's questions coming up. So a little bit about what I've been involved in. I have tried all the patterns. I've tried 14 mask patterns for DIY masks that were popular with the medical folks and folks requesting them. And the idea behind that wasn't to invent the best mask or even find the best mask. It was to find masks that were acceptable to do, optimize producing them, because producing a mask that's awesome that no medical place wants is useless. So yay, find the trusted mask. So I've tried a few. I have a review article coming out in 2 days about the 14 different masks. I thought for sure there was no one mask to rule them all. And then I found this mask out of Florida made out of non-woven polypropylene, and it's pretty bitchin'. You still have to sew pretty well, but it's pretty darn cool, and the fit's amazing on a variety of people. And so stoked about that. When I wasn't checking things out to see what to make, I was literally making hundreds of masks out of all manner of material, whether it's the non-woven polypropylene, and the grade that you have to use for that is the kind that's used in bags. It's a higher grade than, say, craft material, or super inventive materials like the H600 halyard, which is the surgical wrap that an anesthesiologist back east discovered. When the fit is good on a mask made of that material, you get N99 filtration. The downer of it is it's now almost impossible to get that material, and it's one-time use. It can only be cleaned in an autoclave because they haven't tested for the efficacy of breakdown via chemical or heat treated or UV cleaning. When I haven't been doing that, I have been figuring out how to create a safe workspace in my makerspace, because the other members of my community wanted to make PPE, but we weren't willing to put them into a situation of high risk. And we're like, well, how do we do this right? And so a bunch of us got together and did our due diligence and research methods and published those methods with the cooperation of open source medical supplies, the big group who's coalescing a lot of documentation. And then when I wasn't doing that, I was working with this bomb team, and we were building and distributing mask kits, allowing people with more time than just me and my single machines to create protective gear for folks. And for giggles, I was like, why just masks? Let's go for scrub caps. Mostly because if I sewed another mask at that point 2 weeks ago, I think I would have lost my mind. It would have all been game over. And there's more, because I'm like that, and I don't do well with boredom. We got people to make tools. I got people to make tools to help me go faster. This is where I could have used a robot. Oh my God, making bias tape, and I don't know how many of you know what bias tape is a tedious, mind-numbing, irritating thing. And the current machines / could be a robots out there are horrible, expensive, and they're made for, you know, your grand to make a really bitchin' quilt, and it does nothing for anybody who wants to make miles. So a solution that would have been programmable and extensible as far as the scope of how much bias tape I was making would have changed the game, for sure. I also partnered in the community with the folks at Neil's CNC to help them organize kitting face shields. They're doing the Budsman design, and they were super ambitious, but they needed logistical support in order to get all the kits together so it could go to proper fulfillment and actually get distributed. And so the AMT community said, we'll be the warm bodies that are going to do that. So I organized a kit line. There's no reason a robot could not have put these kits together. This is a pick and pull line. It's not, you know, it's just carefully counting things over and over and over again. Like, a human didn't need to do that. Creative sourcing for filter materials, and then just connecting people. I have yet to meet the robot that can connect people, but I sense this group might know that robot. I would like to meet that robot. I really would. I learned a lot of stuff doing all those things. That wasn't supposed to be, you know, a humble brag or anything like that. It's to say that basically I had COVID-related attention problems and couldn't focus on one thing, and so did all the things. and learned a lot of stuff. One of the things I learned was a lot about non-standard materials. There are a lot of what's going on right now in the DIY PPE space and on the cottage and just above cottage level creation of this material is that we're dealing with a broken supply chain. The same as big industry is, but we have the license to be a little bit more inventive. So that means using things that are non-standard and often non-uniform. And in that regard, figuring out a way to have something that I could program to do something else over and over and over again with something that wasn't uniform. So not, you know, having machines that can feed a roll of something, that's nice and all. You can get that in industry, but what about when things aren't standard? So what do you do with that? How do you replicate the human hand doing the same thing over and over and over again? Or being able to decide when something is going to jam the machine, or whatever you're trying to accomplish. So here's a little example that I'm posting right now where I took one of the old green NWPP Berkeley Bowl bags, and it makes a really awesome mask. And what's cool about it is that mask takes a filter, so I can increase its efficacy and use. It is washable, it is boilable, and it NWPP has droplet resistance. It is basically a plastic that is molded to look like woven and behave like woven fabric, but is not. And it is breathable. So some interesting non-standard things going on in that space. Here's a close-up of what that material is. That is NWPP. There are a million things in this motion where it's assembly and pre-assembly. If there was a way for me to engage with some steps that I could just feed things into to do over and over and over again, that would be the robot for me right now. I would really enjoy that because I've made a lot of pleats and I'm over it. We would also dearly love some robots for keeping spaces clean, and not just the obvious one. Here's an example of a mechanical device that we built. Colm built this at Ace Monster.
So this is the Ace Monster Toys No Touchy hand sanitizer station. It's designed to fit really any pump style bottle, so you can reuse a soap bottle like we've done here with your own homemade hand sanitizer, or you can use your Purell pump bottles, anything like that. The dispenser shelf is adjustable up and down with just 2 wooden nuts on the back, and then you can just make a different depth of stand depending on what style of bottle you have in it. You would elastic band it onto this stand, just use a rubber band to keep it in place, but it'll just live there. You walk up to it, put your foot on the pedal, hands underneath, step on it, dispenses, and we're good to go. Turn it sideways a little so you can see what's going on. You can just step on the pedal down the bottom here, hands underneath the pump bottle, and away you go.
So that was a mechanical solution. I want a robot that is going to be able to do the same thing with less physical space, be equally robust, but also equally flexible to be able to do things like take whatever pump container I've got available to me. If the technical solutions being presented, especially in times of crisis, require very specific physical and spatial realities and don't have range, it makes them less useful when you can't get anything from Amazon for 2 months, or wherever you're ordering from. Not COVID, asthma, sorry. The other thing is we have safe delivery methods. I would really love for robots to tell me what's going on, what has left, what has come, when I'm running out of sanitizer, if something has been sanitized. I need to know that stuff without guessing and just spraying alcohol and peroxide everywhere. It's not efficient, and it's not necessarily safe. It's a perception of safe. I want a robot to give me real data so that I can be confident that when I tell a driver to come pick up, that this is good to go. And it doesn't have to be like 100% scientific solidity that there is no virus, you know, cells here at all, but a good certainty that this has been cleaned at a certain proximity, this has been used this way, or X many people have walked by, which is where you get into the proximity, the privacy issues. So I know that the things in my hallway may have been contaminated, may not, may need some extra attention, may not. I want to know that stuff. And a robot could do that for me. A little bit about what I'm doing now. I decided that 1 million projects wasn't enough, and killed a whole bunch of them. And now I'm only doing a little bit of community organizing, face shield support, and my new project, which is Distill My Heart. We are making 1,700 masks in 17 days. We were supposed to get our pallet of NWPP bags today from FedEx, but we got an angel donation, so we started already. We already have, since 2 o'clock today, 90 mask sets off the laser after bag breakdown, and those are going to be sewn as soon as I'm done hanging out with y'all. So we expect our first 30 masks to come off the line tonight. And we are focused with this project on serving at-risk communities. These masks will not go to healthcare professionals, with the exception of people who take care of the elderly, do in-home healthcare, and work in skilled nursing facilities. But these are going to homeless centers, social workers, grocery workers. The idea behind all that, of course, is to keep these people who are at very high risk out of hospitals. Keep them out of the hospital. That means that hospitals cannot, you know, collapse during the peak. And that's the thing about it. We look at doing our first distribution of whatever I can get off the line tonight, first thing in the morning, and it'll keep flowing until the 30th of the month. And so I'm interested, folks. Do you got a robot for this? Like now? And if you're interested in more of the project and what we're trying to do and how we're doing it, so that maybe next time something hits the fan, there's a robot, you can come check it out at thecraftyavenger.com /Distill My Heart. We got by the way, it's called Distill My Heart because we got all the bags from the American Distillers Institute.
That's great, Rachel. Thank you so much for sharing that. And so people can learn about your project at thecraftyavenger.com, Distill My Heart, which I just put into the chat. And you can, are people able to donate to you there?
Absolutely. Folks can donate to the project via Ace Monster Toys. We're a 501c3 nonprofit, and it is all super transparent and super organized and super tax deductible. And we have a GoFundMe up, which you can access through the URL on the screen, or you can go around GoFundMe and get us money right away. We are also focused with those donations. One way or another, we're making the masks, whether we get the donations or not. But if we get the donations, we can get them out faster because we can pay industrial sewers and we can pay out-of-work bartenders for manual labor and delivery and things like that. The money is about speed, not whether we'll do this. And
Excellent.
Speed matters right now.
Thank you so much. It does
Absolutely.
indeed. Now, the person who knows if there are robots out there that can do this, most likely is on this call today, thinking Ken, Missy, and particularly Robin have a lot of insights into these problems and the way in which robots can address these. I'd like to ask Robin to give us an update on the taxonomy of how robots are working in the COVID crisis.
Well, Andrew, thank you for having me here. And indeed, we're seeing some things that may be, are at least reinforcing what Rachel is seeing. So let me go through that just briefly. I'm just going to share the screen because as a recovering professor, it's always hard not to, have to show off our things here. So this is all part of work for the Robotics for Infectious Diseases. We have something that may be of interest to the roboticist is a interview series with public health, public safety, and emergency managers. So it's kind of like everything that as a roboticist you need to know about healthcare and all the different ways and things that we're seeing robots in there. But let's look at what we're seeing for the robots being in there. So as of Monday, and this is very noisy, there's probably going to be a lot of errors in it because we're taking press reports, Twitter feeds, YouTube videos, trying to pull them together into unique instances. And what we're finding is that at this point, it looks like there are 21 countries that are using robots in some form. And these forms I've grouped into 5 major categories. Lots of reasons for that. A lot of it has to do with the way things are funded and agency and who is governmental authority. I've organized these 5 areas based in frequency of country that it's used. Doesn't mean it's the biggest use. It means it's frequency of country. So we're seeing mostly, we're seeing a lot of robots being used for public safety and public works. We're seeing a lot for clinical care, then a little bit about maintenance of our work, our economy and quality of life, that laboratory and supply chain automation, keeping things like testing going, you building masks the way that Rachel was talking about. That is certainly a need. We're seeing a little bit of it. And then non-hospital care, things like the quarantine camps, the nursing homes. Now, the darker the color to the lighter is the frequency of occurrence of that particular subcategory based on the number of reports we're getting. And so you can see that in public safety, the big one is really split between quarantine enforcement, basically having drones coming out and yell at you for why are you not inside, sheltering in place. And also we're seeing a lot of countries taking UAVs that are agricultural UAVs and spraying outdoor areas, trying to decontaminate them, and also putting robots that you saw at Fukushima, putting foggers on them, trying to disinfect public spaces. Clinical care, disinfecting the hospitals is a big deal. Telepresence for the workers is a big deal. But we're also seeing the prescription meal dispensing robots, these sorts of things. In work, we're seeing delivery robots helping that for e-commerce, we're seeing for socializing, we're seeing for creative uses. Realtors are showing houses with a telerobot now. And then in terms of socializing, I think one of the most 2 fun ones I saw was one person actually used his drone to walk his dog, so he could take the dog outside without him having to go outside. Another one was in Japan. A group of students used robots to go across the stage and get their diplomas. Laboratory and supply chain automation still remains a big one. The handling infectious diseases, delivery, and this is delivery within the healthcare system. So delivering from a hospital or a public health office to the laboratory that's going to run that test, or handling the infectious materials like the garbage that shows up there too. And the non-hospital care, so much of that is there. Now, here's what I thought was interesting. The most frequently cited uses of robots, if we look not just by color, but by how much of that are these, and they appear to be existing robots. The disinfecting robots for clinical care are almost always robots that were already being manufactured for the prevention of hospital-acquired infections. The telepresence robot, the same thing. These are already telecommuting robots or things like the Envita system that were at Moxie that were already being sold to do this type of tailored for hospitals. The robots I was talking about, the drones, the PackBot, those already existed, already were in the hands of public safety and public works. So those were very easy and they were built to be adaptable. And that's something that we do see in disasters. You don't see new stuff. You see a lot of prototyping and a lot of press, but you don't see that they actually get used a lot because of the maturity. You need the products to be mature because otherwise you introduce more work for the wrong people. But that's a whole different thing that I cover in my book on human-robot interaction. Anyway, getting back to Rachel, the most frequently asked application that we've had from the interviews so far that we've done with the leaders in public safety and epidemiology and emergency management has been they wish that they could improve on handling the infectious materials. They're not as worried about delivery. They don't need the drone to fly across town. They can handle that part. What they're missing is the laboratory automation. That the big thing of why it takes so long to run a COVID test right now is that it takes so many people with certain level of skills to run those tests. They can't ramp up trained people. They don't have that trained people. You can't substitute unskilled labor. So what they would like, and we saw this with the Ebola outbreak back in 2015 when we did a series of workshops with Doctors Without Borders and other experts. And so what they would like is, imagine being able to have a robot cart that followed you around, and you put a person's hand on it and it stuck them, so they got a little a pinprick blood draw, can measure their temperature, that you as a physician could do more a venous blood draw, do a swab, stick the in your nose up 4 inches, immediately put it into the cart, and it would start processing it. And so clunk, clunk, clunk. And then at the end of your shift, you would take it and it would mate up to the other side of the wall, just like they do with urine samples. And then you just grab, the technicians on the other side could grab it and keep going with the processing. So there's all sorts of cool things that can be done. So that was what I wanted to give you an update on. So robots are being used a lot in a lot of very creative ways. And happy to talk with anyone about this. And I think that particularly if you're a startup and looking at how to work with the public health system, come check out our interview series at Robotics for Infectious Diseases. Thanks.
That's fantastic. You were answering the questions as they were coming up as well. And I think we've got a few roboticists in the audience that are wanting to see if they've got solutions, or wanting to share solutions that they've got in terms of lab automation. I think, Bill, you've suggested you've got lab automation. If you want to put some details into the chat, then please share that with everybody. It's amazing how much difference there has been in the 2 weeks since you first talked about the taxonomy for robot use cases. It's really expanded a lot, but I think it's, I was wondering if we would see more new companies. I'm aware of a number of startups that have pivoted to creating, say, disinfecting robots, or something similar to what you were asking for, Rachel, a hand sanitizer on demand for public spaces and things like that. But I'm not actually seeing evidence that they're making it out into deployment yet. And in fact, that's something that Missy Cummings is going to talk about a little bit. She's just done a very interesting paper about that. So let's see if there's more questions for Robin. Please put them in the chat. And I'd like to segue now to Missy Cummings to talk about robot safety and some of the real gaps between prototype and product.
Thanks, Andra. Hello, everyone. It's late my time, so I stayed up late for you guys. It's way past my bedtime.
Thank you.
But I thank you, Robin, for a great segue. I really appreciated you saying that what we really need now is mature technologies. And, you know, I've been doing robotics certification, testing and certification for almost 10 years now. I started out in drones and then kind of did a segue over into driverless cars. And I also work on medical systems. So I work in this field of safety critical systems where the operation of the robot in terms of the drone or the car or the medical robot, it can actually do damage to people if not designed correctly. And so I'll put the link in the side here in a second to tell you about a paper that I've written that's really looking at the maturity of driverless cars, right? So we've heard, I spent a lot of time in my space, and I spend a ridiculous amount of time on Capitol Hill trying to be a middle ground between, yes, these are good technologies, we want to do research and investment and keep building a capacity, but no, we're not ready to have widespread deployment yet. And I don't care what Elon Musk says, you are not getting full self-driving anytime soon. So it's a teeter-totter, and how do you sit on that teeter-totter, and what's the responsibility in terms of regulation and certification. And so, like, you know, I'm an academic also, which means that, you know, I am a mercenary and I work for hire. And so, of course, when a world event happens, all of us try to figure out, well, how does what I do fit into this world event right now? And how can I either contribute positively, which I think is a good aspect of it, or how can I use this to further my means? That's just a reality. And I think that's what a lot of people are doing for driverless cars, because all of a sudden I saw a huge spike in, okay, now we really got to get these driverless cars on the road. Why can't we get them on the road? This is what we need. We need robots driving us all around in some kind of, you know, robo taxi. You know, just until we can get that automatic cleaning robo taxi, that would be a disaster. But I do think the next big area that does have some potential are the robotic delivery cars, right? They're smaller cars, they go slow. Neuro, for example, is one company. They're not the only ones, but I would say they're my favorite because several of my former students are working there. So I think that they've got good ideas, but before we start going crazy with trying to roll out these capabilities, I'm going to share something with you really quick. I'm going to go into a little bit of lecture mode. Sorry about that. Here we go. I just want to explain to you basically, how do cars and people or any kind of autonomous agent, how do we reason? So the example I'm going to give you is true for driverless cars, but it's drones. It's really any reasoning system. Any reasoning system has to go through 4 levels of reasoning. You start out at the basics, what we call skill-based reasoning. Then you go up to rule, knowledge, and expert-based reasoning. And so where do we see that in cars? When you learn to drive, you had to learn skill-based reasoning, which was learning, for example, how to track white lines on the road. Once you did that, it took you maybe 20 minutes to learn that, then you never actually have a problem with that again until your sensors start to degrade when you get older. So once you have the cognitive capacity that you've learned skills, then you have enough spare mental capacity to think about rule-based reasoning. And that's when you start to understand, okay, I see this octagon in front of me. It is a stop sign. It's red. I know that what it means. There's a set of procedures that go along with stopping, and I'm going to follow those when I see it. Then once you have the rules of the environment that you've learned, then you have the spare capacity to start thinking about knowledge-based reasoning. The big jump between rule and knowledge-based reasoning is the ability to judge under uncertainty, right? So this is where you start to see the uncertainty arrow growing. So when you go up to knowledge-based reasoning, you are starting to have to make guesses about the world with imperfect information. So I like to show this picture of a stop sign partially obscured by vegetation. There are many, many, many driverless car computer vision systems right now that cannot figure this out. That if they see some level of partially obscured stop sign, they just cannot see because they don't see the way that we see. They don't see the complete picture. And so they don't judge that there's a stop sign there. And there are a lot of cases, even when they're maybe perfectly there, if you haven't seen the recent case of the Tesla being tricked by a partially modified 35 mile per hour sign with a little bit of tape to make it see 85 miles per hour. You definitely should avail yourself of those articles, because it's a really good illustration of just how brittle machine learning, deep learning is when it comes to perceptual based reasoning. And then we get to the highest level of reasoning where you really have to you have to make judgments under maximum uncertainty. And I love this illustration of this stop sign with these 4 different, you cannot do this. You cannot turn left, you cannot go right, you cannot go straight, and you cannot go back. So I'd be curious, I'd like to see what any driverless car would do in this situation, because what do you do in this situation? You have to break one of these rules. You have to make a judgment. You have to figure out what is the best possible way to get yourself out of the system. And it means that you're going to have to break rules inside the system. So the expert-based reasoning, knowledge-based reasoning, they're at what we call top-down reasoning. It's you taking experience, judgment in the world that you've had, as you've gotten older in life and had more experiences, you bring that to bear to make better guesses about what you should do in the future. Bottom-up reasoning is essentially what is happening in machine learning. You're taking all the bits and bytes of information from the world and then processing that to then make some kind of action. So right now, computers are really good at skill-based reasoning, some rule-based reasoning. Humans are really the best at knowledge and expert-based reasoning. And this is something we call function allocation. But the problem is there's a big break between rule and knowledge. Driverless cars cannot do this right now. Until we can make that jump into knowledge and expert-based reasoning, and I'm gonna, again, I'll put the link into my article to talk about what is it gonna take to do that, what are we gonna have to do. We just simply are not gonna get there. And why that matters is, now how do I unshare that screen? Stop share, okay, let me go back. Why this really matters is, I don't know why we're saying iPhone.
I'm seeing you, so.
Oh, okay, good. Okay, okay, fine. So somebody's popped up iPhone. But why it really matters is we're starting to see in, you know, in practice, there was the Tempe, Arizona crash where the pedestrian was killed by an Uber vehicle. Tesla, you know, even though he claims that they've got full self-driving, the National Transportation and Safety Board just released a scathing set of reports. We ourselves in my lab have been doing testing of Teslas. I will release this report in a couple of months. It'll be very controversial, but we've been taking Teslas to a closed track and putting them through some trials. And I'll tell you this right now, it's all over the place. The software release, the sensor capabilities, the sensors on the cars. We have got to come together as a community to figure out what it's going to take to be good enough. We need a set of vision tests. We need a set of performance tests for these cars, because what we don't want to do is release a bunch of delivery driverless cars, which agree they go slower, but Easy Mile was just shut down because the cars themselves, the slow shuttles, were having a problem. If we as a community kill someone, if a kid in a neighborhood where a driverless shuttle is doing delivery gets killed, the whole community is going to be set back. So I am really strongly advocating that we as a community come together and start to self-certify. Let's come up with the rules. Let's come up an agreement as a community, what we think is safe, what we think is safe enough, not perfectly safe. I am not saying that these cars can never make a mistake, but we need to come to an agreement about what we think as a community is safe enough to put these cars on the road, because if we don't, and then someone gets killed, it's going to be all over.
And that is very strong points. Robin's added another one there. We need to mandate for testing for human out of the loop as well, not just standalone autonomy. And from the content of your paper, I think the problems are so significant, the brittleness, as you put it, of the blending of both top-down and bottom-up approaches, the multiple changes that we have in sensor fusion. In fact, diving further into your article, I was a little dismayed to realize that the technology readiness levels didn't factor in software. All of these things that we assume are better understood or more reliable or better able to be evaluated than it really appears they actually are. So I can see a need. I don't know how we can bring in, I'm really not certain what to aim for in a standards discussion. And I think it's really good that we're having this discussion now. In fact, there's some more interesting questions coming through from, we'll just ask a couple of these questions because I do want to move on to Rex and to Ken to say something.
I actually just want to say real quick, I just saw Ken say that I was an Air Force pilot. No, Ken, I put this background up for you. I was a Navy pilot. So
okay, I got that wrong.
You got to know where the best pilots are, Ken.
Definitely.
My mistake.
Oh, well, so it's a very interesting discussion starting here. And I think what we're going to do now is just field a couple of these questions, and then we will move on to Rex, and then to Ken, oh no, then to Michael and Steve Cousins, if he's just joined us, and then to Ken, if that's okay. But Ken, if you have anything particularly in response to what Missy's saying, please dive in.
No, just bravo. I mean, I totally agree. And I think what she and Robin and Rachel have all been emphasizing are really interesting facets on this. And the safety issue is so important, because if we just put things out without testing them, it can actually set the field of robotics back and put us into a robotics winter that I really do worry about.
Excellent. Now, there was a really fascinating question about how do we think privacy and data protection fit within self-certification or regulation of AVs? That's a fascinating combination. I think we're going to have a whole session on the issues of privacy and data protection and how that fits into robotics and autonomous vehicles. And then maybe we can start to look at how the safety aspects also fit in and around that discussion. I think maybe those two things have to be looked at in depth separately, but they both need to be looked at. It's not just safety and it's not just privacy when it comes to that. Now, Rex, are you available? Would you like to share with us your really interesting projects with us?
Well, thank you, and thanks to everybody else for sharing the work you've been doing. So I work at ARM during my day job, and I do a lot of developer community activity, and I also run across robots quite a lot. This isn't quite a robotics topic, but a few weeks ago, I began working on a project called Rosetta at Home. So if you're not familiar, there's a lot of researchers that are studying protein folding and other aspects of biological research, which I don't understand. And they don't have the funding to pay for supercomputer time. So what they do is they distribute their research workloads to a volunteer network all around the world through this program called BOINC. So there's a lot of these programs. There's SETI at Home and Rosetta at Home and Fold at Home. And there's all these people that volunteer their extra compute cycles by downloading this client, and then researchers upload work jobs to the cloud, and then those jobs are distributed to these home computers. So because I work at ARM, we realized that Fold at Home and Rosetta at Home, these are two projects which are used specifically to study protein folding. They did not have ARM 64-bit clients available, which means you can't run them on a Raspberry Pi 4, you can't run them on some of the newer ARM hardware. So there are a lot of people in the community that were wanting to help out with Fold at Home and Rosetta at Home, which are now being used extensively by researchers specifically to study COVID-19. So we put together this community project. I'm just going to share what I'm doing. And it came together very, very quickly because everybody, once they learned about this opportunity, they jumped on board very quickly. So what happened was these guys from Neocortex, it's a startup out of San Jose, they jumped on this, and their CTO ported all the key libraries from Rosetta at Home to ARM64. And then within a couple weeks, a week or two actually, we're now up to 793 ARM 64-bit devices that are supporting researchers studying COVID-19. So anybody that wants to help out, if you've got a Raspberry Pi 4, it needs to be Raspberry Pi 4 or ARM 64-bit. You can install Rosetta at Home on your Raspberry Pi 4 and begin crunching on proteins to help researchers fight back COVID-19. Or you could use your, NVIDIA Jetson or x86 box. You could use whatever computer you've got to help to support this cause. So Rosetta at Home is one project. The other one is Fold at Home, and we're making really good progress on porting Fold at Home over to ARM64. You can again contribute to Fold at Home, likewise, same as Rosetta at Home, by downloading the client. So if you're into ARM, you can join. I think there's a team. It's Crunch on ARM or Fold on ARM or something, and we're diligently tracking how many people are helping out on ARM. So this guy, Mini Nodes, his name is David Tischler out of Arizona. He works for a startup called Baylina. He did a ton of work to make this. So you can see this is the spike protein right there of COVID-19. COVID-19 uses the spike protein to sort of latch on to the receptors of human cells, and that's how it kind of invades your body. So they're doing a lot of work to understand the structure and behavior of that spike protein on Rosetta and Fold at Home. So announcement is tomorrow at 10 a.m. In partnership with the Washington State IoT Council. Lloyd and his team are going to present their work, and I'm also going to have the Rosetta at Home team there. And I posted the Eventbrite link in the chat if anybody wants to register and learn more about how you can donate your compute cycles to studying COVID-19, help researchers out. So that's, and here's the Eventbrite link. I'll post it in the chat again. There's some questions. What do I click? There's questions. Okay.
Stop screen share, and I've just posted the link for you.
Oh, yeah.
That's
Okay,
a fantastic project.
All right.
Does this actually make this the largest supercomputer in the world?
I don't know. NVIDIA posted about Fold at Home, posted an article on Fold at Home asking for support, and that caused I think they had 30 or 40,000 people helping, and then it went to 400,000 within a week or two. So Fold at Home became extremely popular, and if you follow the Fold at Home Twitter, they post regularly about how many exaflops, I think it's exaflops, are now in their pipeline. So it's escalated dramatically, the amount of compute power that's targeting these researchers' compute jobs.
Wow,
and that's it. Yeah,
that is a fascinating project in addressing COVID. I really am excited about the opportunities there, and I've got a Raspberry Pi 4 in my drawer, not doing anything useful, so I'm just going to have to crack that open.
Thank you.
And I saw in the chat as well someone from the NASA team discussing the TRL for software project that Robin and Missy in particular was in your paper. Someone is on the web. Someone's on this call right now, and some more great questions. But I think what I'm going to have to do is move to our next speaker, because we have an abundance of really interesting content, and that will be you, Michael. And if Steve's online, I'm seeing if I can find him by name here.
I sent him an email, but he responded saying he didn't RSVP, so I sent him the link. I'm not sure if he's gotten it yet. Hopefully he'll be able to join us.
He may be there, but I don't see his name. It's possible he could be that anonymous iPhone. If you are there, Steve, just ping me in the chat and I'll be able to find you and make you a co-host. But in the meantime, Michael, would you like to introduce yourself and talk a bit about what you're working on?
Yeah, sure. My name is Michael Sayre. I'm working with a company called Cognicept as CEO. We're essentially solving a lot of the problems that Missy highlighted, which is that, when we look at autonomy and moving robots into the real world, there are a lot of complexities about the real world that cause what we call edge case failure in these systems. And so what we've built is essentially a system that allows a confused robot to dial out for a human operator. That human in a loop's not a new idea. I mean, this is something that self-driving cars have used. There's been a lot of this human in the loop practice done in the past. What we've built is essentially a system and a service that allows this confused robot to dial out for help on a real-time basis. We essentially listen for intervention requests from the robot, so that can be an error code or some kind of failure of the system, timeouts, whatever it is really. We can listen for that event, and then we cause a ticket to be registered in our system, which our operators will then see. That connects them to the robot. They can kind of get a sense of what's happening in the robot's environment. They can get sensor information populated in a 3D canvas. We can see videos and so forth that allow the operator to make judgments on the robot's behalf. So if, for example, you had an occluded stop sign, or self-driving vehicles is probably not the best example for us, but maybe you would be able to use our system in something like a last mile delivery vehicle, which will face a lot of the same problems. Maybe the robot's uncertain about whether it can cross the road. We can have a look at the video feed from that robot, understand what maybe the traffic signals are saying or what the environment looks like, and then give the robot a command to essentially help it with getting past the scenario that caused that edge case failure. So we see this as sort of a way to help get robots into more useful service. Right now, even a 1% failure rate for a lot of these applications can be a deal breaker. We, especially for self-driving cars, as everybody mentioned, the cost of failure is really high. But even in other sort of less critical cases, like in-building delivery, you see, if something is spinning around in a circle or not performing its job, it causes people to lose confidence in the system. They stop using it. And it's also, during the time that it's confused, not performing its function. So we essentially built this system as a way to bring robots into a broader range of applications and improve the sort of uptime of the system so that it doesn't get into these positions where it's stuck during its operation. Actually, I have a little visual aid that I can share here just to kind of highlight some of the types of cases that might confuse a robot. Let me just pull that up. Yeah, so essentially what we see here is that, we all know, we've seen this before, the 3Ds, robots are great for things that are dull, dirty, and dangerous. And in many cases, robots will physically outpace humans. They don't get tired. We've seen Atlas Robotics with backflipping robots, and most people can't do that. But robots don't understand some fundamental things about the world that people take for granted, like you and I can easily tell which of these is a chair. A robot may struggle with this. Similarly, we have robots that get lost in spaces that are widely variable. So, a warehouse that has boxes or pallets that move in and out of the space very frequently, that's going to confuse the robot because its internal map is static in most cases. And when you have a very large change, the robot's going to get confused about its location and then not be able to proceed with its normal operation. That's something that we can help with. We essentially will be able to look at the robot's environment and understand where it is in its space and then update its location. Again, we look at different types of obstacles. A plastic bag is not really an obstacle. We can run through that. But on a LiDAR, it shows up the same way as a pile of bricks. The same thing with a trolley. We know it has wheels as people. A robot may not understand that. And so it's going to operate in a much more cautious way that limits its usefulness. And so by having a human in the loop element, we are able to sort of handle these edge case failures and get robots to perform functions that they wouldn't otherwise be able to perform, and be useful in applications that were maybe too challenging for full autonomy.
That really leads into what Missy was talking about proactively developing standards. Do you find that do you already have a good idea as to what you would consider non-critical, as in something that you would farm out, and what time duration, like what speed things would happen at, and what distance for, say, surrounding people would have to be? How do you categorize what's an acceptable use for what you're doing?
I think a lot of it has to do with sort of how dangerous is the robot in question. So, for a self-driving vehicle, it's very dangerous, right? We've got a half ton of steel, moving at, relatively rapid speeds. This is a dangerous system. On the other hand, a lot of in-building delivery robots, like we're doing some work in quarantine zones, making deliveries in building that allow the social distancing to be maintained. Even though people need supplies, we can put the supplies inside of this delivery robot and send it in a building to the delivery room, the room that the recipient is inside of. These are very small, and they operate at very low speeds. So worst case scenario, we might bump into somebody's shoe. So these are, I'm not sure to exactly answer the question, like how we define it, but I think that, a big part of it is, what is the robot doing? And sort of how big is it? How dangerous is it? If the answer to that is that it's not very dangerous and that its failure doesn't cause sort of safety concern, it's just inconvenient, and might sort of ruin either the economics or the usefulness of the robot, that would be a good case for these sort of like less critical systems. So things like in-building delivery, material handling in logistics spaces, maybe like a picking arm, like a robot arm that does pulling things out of a box and putting them into a shipping container, or into another robot for in-building delivery, maybe in a quarantine zone. I think stuff like that are good candidates for for the system that we employ. Where you're going to see problems is anything that is extremely massive, moves very rapidly. These are not good candidate for a sort of human in the loop function, because those response times, while we try to get it as fast as we can, you're still talking about 30 seconds maybe before you can really respond to the problem in a meaningful way. So 30 seconds is an eternity for a self-driving vehicle, whereas for an in-building delivery robot, it's not a big deal. So I think the answer to that, it's pretty application dependent and also system dependent. How dangerous is the system inherently?
That's excellent. We've got some process on the front for standards, on the standards for mobile robots front, but that's still in very limited use cases. I think we can perhaps as a community start to pull together some more of this with the information that you're getting on edge case scenarios that can feed towards setting appropriate guidelines. So,
yeah, definitely. I think that a lot of the standards that do exist were sort of built around the concept of dumb robots, where they're not really examining their environment. They're performing repetitive tasks that were pre-programmed. And so the sort of solution has been to cage it off from humans. And most standards sort of build this assumption in that you're going to have is minimize the interaction and tightly control the interaction between humans and robots. And that really leaves a lot on the table. It doesn't take full advantage of some of the advances that we've seen in smart robots over the past 10 years. So I think there does need to be an update to the standards. And we think that, some of the information that gets collected by companies like ours and companies like Savio and companies that basically have these robots in the field, smart robots performing these functions, they're going to be able to capture a lot of valuable information that help us set those standards.
True, and we might need to have some sort of validation that the sensors and software are able to reach the appropriate technology readiness levels. I was fascinated by the figures that Missy has in her paper around the amount of budget blowout, for example, in projects, because something that was expected to be ready to go into production was still really at a prototype level. So as things are evolving rapidly, we need to be able to separate out what is actually a reliable or a mature technology. That's Ken, do you have anything to add to the discussion so far? It's covered such a lot of range. I think we could easily keep going for another hour, but I'd like to hand over to you before we do run out of time.
All right. Well, I do want to yield my time if there's other speakers. I'm hugely impressed with the range that you've brought together, Andres, tonight. I mean, between Rachel, Robin, Missy, Rex, and Michael, you've just covered so many new and interesting areas. If I can, I do have one thought that I'd like to share that occurred to me this week, which is that I think I wonder if we're shifting from what used to be called the high-tech, high-touch concept, that there was this prediction from Michael Nesbitt from Megatrends that we were moving, as we got toward more high tech, we'd also just as much crave the touch. And I wonder if we're moving toward a low touch future where we actually will see a new value in things that don't involve touch. And I can tell you, it's so interesting for me to be to be in the house. I've gotten a whole new appreciation for things like washing machines and even vacuum cleaners. I mean, they're incredible, these mechanisms that help us do things that involve, rather than us reaching down and touching everything, that basically do it for us. And I've been thinking about, before this pandemic, there were a lot of things out there like robot vending machines that I was a little skeptical about, and I thought, well, I don't really see what's the big advantage. If given a choice, I'd rather have a human making a hamburger or a coffee. But now I'm starting to really think, I think that equation has changed. And I wonder if that's going to change permanently. In other words, are we actually going to see this, a real trend toward things like these robot coffee making baristas and robot burgers like Creator, the company in San Francisco, Robotics is developing fast food making robots. And then I think it's time to really reevaluate those, because I think there is going to be an actual appeal, a visceral appeal toward this kind of low touch future.
And we know that there's valid reasoning from food safety perspectives usually, and particularly when we're trying to do social or physical distancing, there's an incentive right now. I was reading today that it's predicted that we're going to be needing to do so. We're going to need to implement these practices pretty much for the next 2 years. Maybe not all of them all at once, but that it's likely that we're going to need to have this change in the way that we live approach. So it will be interesting to see how that bears out. Someone was reflecting on how similar it was to the polio outbreaks that used to happen, and they would just significantly change the way in which people would interact there. Now, we did cover a heck of a lot of territory today, from Rachel saying, "Where is my robot?" to Robin saying, well, here are all of the different robots that we are seeing coming into play, but most of them are mature technologies that were pre-existent. And we've had Missy explaining why we really need mature technologies, because the startup culture is leading us to really rush technologies that are still at prototype stage, that are not really mature enough, but where we think that they're ready. And that's costing a lot of money, and it's causing a lot of problems in safety perspective. We've heard about another way in which computation is working with research in the COVID crisis. We've heard about delivery robots, and the way that teleoperation is probably the best way forward in terms of autonomy, is to have robots as an augmentation or as a low touch device, as Ken's talked about, needing to have more of low touch in our environment, just to try to capture a little bit of a very broad discussion. Technically, we've reached the end of our time, but we've got so many really good questions. I'm hoping that we can spend just a little bit longer and maybe address one or two of them. For example, are there any robots doing the nasopharyngeal swabbing? I see, Robin, you've been answering that in chat a little bit. And another one, will COVID accelerate robotics development and then accelerate the displacement of the traditional workforce, further impacting national economics? Well, I have to say, I would like to field this one. I think our national economy is already disrupted. You know, if anything, what we're looking at is robots to fix some of the broken pieces in our supply chain, and to fix some of the really dangerous work practices that are happening. Grocery workers should not be confronting disease in this way when they go into work, and yet they're an essential service, the provision of food, let alone the health workers who say loud and clear they didn't sign up to get sick and die. They signed up to help people. And so we shouldn't call them heroes or martyrs, because they don't want that part of the job. They just want to be able to go to work in safety and continue helping people. So we have an urgent mission, all of us, to create more robots for the benefit of the people who are currently at risk in our grocery stores, in our public transport, the underserved communities that are not having access, and particularly to our health professionals. Well, that was kind of a bit of a rant from me. I think I will finish the recording at this point. We do have great links that have come up in the chat, and I'm certainly looking forward to our next discussions. And I want to thank everybody for being so fantastically involved and engaging today.